Okay, so guys, for your assignment today, first couple things, I'm not going to require you to draw. I put these in here for us. This is kind of a simple series circuit. Instead of just having one resistor, though, there's three here. And then for a parallel circuit, you pretty much need at least like two resistors in order for that to be a thing. Now, once we scoot down here and we click on this, it is going to bring us to this website in which you guys need to the hell is this? Get this out of here. Don't want that. Thank you. All right, so it says here to build a simple circuit with a battery, battery wires and a light bulb, and then over here to draw it. So when we go into this, I want to put in a battery like so. You got to click on it and drag around. All right, you can then click on it and move it. Now, me personally, I'm gonna like to have it kind of like in a vertical orientation, like so. So you have these terminals here represented by these red dots. If there's nothing, all right, if there's no connection made, they're still going to be red. Yes. You can just do the intro. Sorry. Yeah, so we're on the intro. So I'm gonna kind of basically walk through it with you guys, so that way you have kind of exactly what you need to do. Okay. So I would click on the like a piece of wire. You got to click on it and drag it around. And so when you get close enough, it should snap to one of those little pieces. And then if you don't like let go, it's gonna kind of still move. So I'm gonna let go, and now I can see that there is connection made. This little red dotted circle is now black, and then I can go to the other end and drag it, make it longer, whatever I need to do. So here I'm gonna go like this. Take another piece of wire, go like this. All right, I like to, me personally, I try to, if I can, um, make it square-ish, rectangular-ish, if I can. But on this simulation, it's a little bit difficult. But so now it said in here we needed a battery, wires, and light bulb, and it's got to work. Okay, so battery, light bulb, like this. Now, the light bulbs had two of these red circles. So one of them has to get connected, all right, to one spot on the wire, and then another wire has to connect to the other end. Now notice nothing's happening. No electrons are moving, no current is flowing. So I have to have a complete path like so. And now you can see that the charge is flowing through there because there's a complete path. And there is still a complete path here for this guy. So from one part of the light bulb to the other. But if I were to have accidentally cut this here, and I try putting this connecting wire on the other path, not this one, what might probably happen is there's an overload. All right, there's way too much current flowing through, not enough resistance, and it's going to overload and overheat. So we don't want that. So I'm going to cut that guy here, move this wire again to one spot on the light bulb, and then like so. So then what you guys need to or should know how to, you need to figure it out how to do it, would be to like screenshot or snippet tool on your laptops, right? So for me, I know how to do it a little easier. If you don't know how, you can Google on how to do it. So I click, all right, that, and then I'm going to go in here and I'm going to hit Control V to paste it in. Now I can double click on it and then these little black tiles kind of show up. Allows me to crop this. So that's what I'm going to do, just so I don't need all that extra stuff in there. Click outside of the picture. Great. And I can drag it and make it a little bit bigger. Okay. So here it says, do a drawing of this circuit here. It would pretty much just look like this, right? A battery, wire, and one resistor instead of having three. All right. That's pretty much what you would see. And we don't need all this extra space, so I can kind of then it asks, what are the main differences between what you see on the screen and what you would draw in your circuit diagram? So this is what we would end up seeing on our screen. This is what our circuit diagram would essentially look like. So what's the difference is, well, in this, I can see the flow of the charge, right? I can see the current flowing through, and I can see that my device is working. I can see that the light bulb is lit. All right, that's lit. I like that. Ha, just kidding. Okay, so you would basically type that in and say that down here. All right, that you can see the um, the current flowing through the circuit, and that your light bulb is working. If you were talking about like a regular circuit diagram, right? Yeah, you have your battery. You know that there's a complete conducting path, but you don't see the flow of the charge, and you don't see like the light bulb turned on. What flows through the wires when there's a closed circuit? So a closed circuit is when there's like a complete path. So this is like a complete closed circuit. Now, if I want to take something off or disconnect it, I'd have to click on one of those little junction points and then hit this little cut with the scissors, and then it separates. This is an open circuit right now. Nothing's happening. So for the closed circuit, all right, yeah, you're going to have all that kind of good. All right, so what flows through the wires? All right, you're going to see the electrons moving through, the current moving through, and what on the screen represents it? The little blue circles. And then you would pretty much write that down in there. Now again, here circuit diagram. So what they wanted you to do is keeping it as a simple series circuit. So it's just again a series circuit has one path for everything to move through. All right, so it's got one path. Right now, if you like pretended like this R1 and R2 wasn't here, this is what we would have. We'd have that drawing. So down on part 1 for the series circuit, they want you to have number of light bulbs, all right, for 1, 2, and 3 bulbs. And then over here, indicate which one is about the relative brightness of the light bulbs. So like go to the brightest, least bright, and then bright. All right, those are going to be pretty much our three options. So since we already did a circuit diagram with one bulb, I can pretty much just take that and use the same picture. What I'm going to do, I'm going to crop this down a little bit. Okay, and then just going to make it a little bit bigger. Now, I'm not going to tell you whether or not it's the brightest or least bright right this second because I haven't done it with any of the other ones yet. So then I'm going to go back into my diagram. All right. So you could like redo it, or we can do a couple other little pieces of information. I'm going to cut this, going to move this, and I'm going to add another light bulb. Again, the red circle, that junction point needs to be on one spot on the light bulb. And then I need another conducting wire that can connect here. So now that I have two light bulbs, so what do you see here? What do you notice about this one? Well, there's two things that you should notice. So if I cut that out, right, and just kind of put the wires together. Look at the relative speed of the electrons, right? Look at the relative speed of the current, how quickly it's moving versus, and the brightness of that light bulb versus this guy. So it seems like the current has slowed down a little bit, and the light bulbs definitely don't seem as bright. So again, you would figure out how to screenshot and then paste it in here by Control V. Or if you have a MacBook, I'm not 100% sure on how to work that. Okay, and then I'm gonna just crop it up a little bit, make it a little, blow it up, and make it a little bit bigger. Okay, and then we need to do 3 light bulbs. So I would go back, cut here, and now I need to have add another wire. Now if I did this, it's pretty much the same thing as what we just had, but I need an extra light bulb. So I'm gonna take this guy again, it has those 2 junction points. One connects to that piece of the wire, and then scoot it there. Okay, now again, what should we see, or what should we notice? That the current is moving even slower than it did. And what about the brightness of the light bulbs? They should be less bright, or even dimmer than our 2 light bulb piece. Just crop this down a little bit. Come on, buddy. All right, good, whatever. So we have relative brightnesses here. Which one is the brightest? Yeah, that would be definitely 1. This one is bright, but it's not the brightest. And then this guy would be, right, the least bright. Okay, so what can we conclude about what happens to the brightness of the bulbs as we add more in series? So what can we conclude? We can conclude that as we add more light bulbs in series, the brightness winds up decreasing. And why do you think this is the case? And then again, you can go back into the notes and answer the question and use this to help answer your questions. Okay, so the more components you add, the more total resistance you're going to get. All right, so more resistance means there's less current flowing, and less current means less brightness. So pretty much like those two, or 3 things would be like something you would want to add into your answer here. Okay, so then we have to do a parallel circuit with one with 2 light bulbs and one with 3 light bulbs, and then rank them for the brightness. So again, what does a parallel circuit look like? So a parallel circuit looks like something like this, where you have multiple paths that lead back. So here, there's only one path for the electrons to flow, and over here, there are at least two. There has to be at least two for a parallel circuit. So we're gonna do our best to attempt and draw that, or design that over here. So I'm gonna restart. Take a battery here. All right, again, doesn't have to be, but I prefer it to be vertical. All right, let's stretch it maybe to like there. Go down, right, maybe about there. I'm gonna put in one light bulb here. Okay, so this just right here is a series circuit. One complete path. But a parallel means there's more than one path that the electrons can take. Now notice what's going on over here. There's no movement of the electrons on this piece of the wire because there's no difference in charge on any other end. Here, there is. So we would need at least something like that. Uh-oh, what happened? Blew up. Why? While that's happening, pretty much that enables a path for the current to just go all the way around without like losing any speed of going through this resistor here. And it's going to be too fast, too much, and it's going to overload the battery and pretty much blow it up. But again, right now, there's still no electron motion over here. We're going to add our other light bulb in. So this is our first one that we needed. Okay, so here's our light bulbs. So this would be our first one. This is our first parallel circuit. Now look, you can see right around here in the center, right? Like some of the electrons go through this way, some go through this way. Now I can crank and increase the resistance. If I click on them, I can increase the resistance. So if I did that, just curious. What did we just see? I increased the resistance. What do you notice about the speed of the current through here, through this loop? Look how slow these guys are moving in comparison to these guys. And why is that? Because I increased the resistance. And now if I decrease the resistance, what do you notice about the light? All right, if I decrease it, it gets brighter. And also look at the speed of the guys going through here. They're moving at a much quicker rate than this guy is over here because he's at 10 ohms. This one right here is at 3.5. Well, let's keep them all the same. So 10 ohms. Okay. So with this, I'm going to screenshot it and I'm going to put it in here. Kind of crop this down a little bit. And we can make it a little bit bigger. All right. And then we needed to do one with 3 light bulbs in series. So we go back. Now we need a third loop, third path here. Whoa. Okay. And what do we see here? What's going on? Yeah. I mean, it's going through, right? They all look like they're going about the same speed. And that is because, again, this guy's at the same level of resistance. And there's multiple paths that these things can go through. And because of that, if you notice, the brightness of these things did not change. Right? So, like, see how, let's say, like, this light bulb goes to about this level of brightness, almost like a full mouse length from this, like, circle from the top of that junction point. So, if I connected this, still almost that full same length. So, the brightness here didn't even change. The brightness level didn't even change when I added another light bulb in series. But let's see, did that anything happen with the current? Let me cut this. Yeah, so the current stops over here. But all right, let's see if I don't know if I'm the only one that can see it, but if I'm, you guys help me because I'm looking at it one way. You guys may see it a different way. What do you see? Does the current change speed if I attach this guy here? All right, let's see. Right now, so it speeds up a little bit, right? So it's sped up a little bit. Okay, so that's good. We keep that in mind. Okay, so here's our three bulbs. I'm going to screenshot that. It's gonna fit in here. We're gonna crop it down. I can even make this just a wee bit bigger. Okay, so the overall brightness. When they're asking like which one is used the brightest, least bright. I don't know if it was you guys or just you or me, but yeah, the same level of brightness. What can you conclude about what happens to the brightness of the bulbs as you add more bulbs in parallel? Well, yeah, they're going to have the same level of brightness. And why do we think this is the case? Hmm. That I think that has something definitely to do with it. Let's see if we have anything in our notes here that may help us out. So, in a parallel circuit, pros and cons, right? The more devices does not decrease the current. So that's not going to change, right? How that goes. So if it does not decrease the current, so maybe when we said that, does it change the speed? Let me see that again real quick. It doesn't yeah, it didn't decrease the current at all. So that's a good thing. Okay, we're here, and then let's go into this guy. Now, if one of them were to break, all the other two bulbs, all right, stay out. What is a problem with something being in parallel? Well, the current doesn't stay the same for the entire circuit, so energy can be used up quicker. And then if the total current increases, faster electrons, hotter the wire, chances of fire. So let's see, right? If we did this, click on this guy. If we decrease the current or the resistance in this one guy, then you see how much brighter it gets than the other two. And look at the speed of this. Whew. This guy's flying. Look how slow these two dudes are moving. They're just chilling. They're just chilling. Let me see if I Uh-oh, we're reducing this one too. Woo! Too fast. Too fast. So there's pretty much no resistance here. The current is like free reign. It is basically not even going to bother going down these two loops, and it's just going to go through and burn it up. Still, if it's too small resistance, it's going to overheat. Okay, like it's very care. You got to be very, very careful to what level of resistance, right, things are in parallel, or yeah, the whole thing can go up. So I'm just gonna throw them back to where we were. We're about 10 ohms each. Take it easy, guy. Then nice. Now, if I increase the resistance on this guy, he's very, very dim. And look how slow them electrons are moving. All right, the current is flowing through this loop over here. Very, very slow. Not nice. We don't like. Splat. Bang. Okay. Cool. 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 Nope. Nope. Um. Okay. So how then? Conclusion questions. Okay. How does the parallel circuit compare to the series? Pretty much one of them has one path that electrons can move. All right, only one path, and as you add more things, they get less bright. These guys have multiple paths that the current can move, and by adding more, it did not change our level here of brightness. What would happen if you break a parallel circuit? All right, let's see. What happens if one of these things break in a parallel circuit? Well, let's just say the middle one breaks. The two other light bulbs stay on. The other things in the circuit can still work. So if there's a break in the parallel circuit, the remaining pieces will still work. But if we were to do that in a series, which would be like this guy, right? If I had a, let me break this off for a second. So now we're looking at a series just over here. If there was a break in that, or the light bulb here, the resistor broke, the whole thing shuts down. And even if there were multiple pieces in there, all right, everything would stop working. So those would be a couple things you would want to deal with and write in. And then what are advantages and disadvantages of series and parallel? All right, those are in the notes that you can pretty much just copy straight through. Okay, let's see where I know it's in here somewhere. Oh, here's some advantages and disadvantages of your parallel circuits. I didn't know if I put anything in here for the series. Well, for the series, what is like easy about that is that it's a lot easier to design. All right, and it's going to wind up probably being also a little less expensive, and the calculations and stuff are a little bit easier for someone to wire it like that. But yeah, a con would be if a path or like one of the resistors breaks or the path gets cut off, everything else that's on there would stop working. So you're going to want to mention something along those lines in your conclusion questions, okay?